All right, hi folks. We're going to finish up the last part of our Chapter 6 notes on chemical bonding. We've talked about ionic compounds, we've talked about molecular compounds, so now we're going to finish up just touching on acids. Now, acids have their own naming system. We're not going to learn that. I'm just going to ask you to write down a handful of the most common acids that we're going to be working with in class, and then you can reference these for their names. All right, so first of all, acids. Let's get a definition. They are compounds that produce hydrogen ions when they're dissolved in water. Okay, and we'll be taking a look at this more as we go. You can consider them to be anions combined with hydrogen ions. So hydrogen ions are going to form a +1 ion because they're going to lose their electron and have just a +1 ion. So that's what happens when they're going to dissolve in water. They also cause electrical charge to be able to flow. One thing for recognizing common acids is just that they start with H. So you might think, well, water starts with H. And that's true. Water is actually the most common acid and the most common base. Okay, so it can act like an acid. We usually don't think of it as an acid, but it can act like an acid. So here is our list of common acids that I would like you to be familiar with. Notice these all start with an H. So the first one we have hydrochloric acid, then we have sulfuric acid, nitric acid, acetic acid, and phosphoric acid. If you notice, um, sulfuric acid is made with sulfate, SO4. Nitric acid is made with nitrate, NO3. Acetic acid is made with acetate, C2H3O3. So those are polyatomic ions that have, instead of bonding with a nonmetal, they've bonded with a hydrogen, okay, that has formed an ion. And again, when these guys dissolve in water, they let out hydrogen ions. And a lot of these are corrosive or they burn your skin, but we use these a lot in chemistry. We're going to be using them in a lab. So it's important that you're able to recognize these are acids from their formula. Again, there's a whole other naming system, but we're not going to learn it in this class. So just be familiar with these acids, and the big thing is be able to recognize it because it starts with an H. All right, moving on then. And again, because it's a video, you can pause and write down the things that you miss if I'm going too fast. So let's talk about using these chemical formulas that we've spent so long learning how to create. So one of the ways we can use them, we can use these formulas to find molar mass. We already learned how to do that. We can take the atomic masses, which are the molar masses off the periodic table, and figure out how many grams per mole are in here. So like the molar mass for barium nitrate, we can send barium's atomic mass, nitrogen, oxygen, add them together and figure out how many moles are in 1 gram of that. But today I really want to talk about percent composition. We can use the formula to determine the percent composition. So what I mean by that, we can figure out in an element like H2O, just pull a pen out here, in an element like H2O, we can find out what percent by mass, so like what percent is made up of the hydrogens and what percent is made up of the oxygen. This is important because hydrogens are much, much smaller than oxygen. So by mass, more mass is coming from the oxygen than the hydrogen. Okay. We can do that using this formula. So please write this down. You should be writing down everything. But grams of the element divided by grams of the compound times 100 gives us the percent composition. So these give us, this formula is going to give us the percent composition. And we're going to do an example together right now. So my question, what is the percent composition of copper 1 sulfide? So first of all, we're going to have to write the formula. All right, so here we go. First thing, we have to figure out the formula. So we have copper. Now copper is a transition metal, so we have to look at this Roman numeral. This tells me the charge. So it's going to be copper with a +1 charge, and we have sulfur, sulfide. I know that it's just sulfur, not sulfate, not a polyatomic, and that has a -2 charge. Again, you could find these subscript these charges on your pink sheet. Okay, so we're going to do our crisscross, so our formula ends up being copper. The 2 is going to come from sulfur, and so copper 2, Cu2S is our formula. So now with this formula we can figure out percent composition. Here's how we do it. We find the molar mass of each, okay? So I have copper. This is back from chapter 4. Yeah, chapter 4 we learned how to do this. So in our formula I have 2 of them. So I'm going to take 2 and I'm going to times it by its molar mass. Remember, its molar mass we find on the periodic table. For copper, it's 63.55. And again, this is found on the periodic table. It's the red number on our periodic table. Okay, so that's how many grams per mole there is. So 63.5 times 5 is 127.1. Okay, do the same thing for sulfur. We only have one of them in this compound. And sulfur is 32.07. All right, so obviously 1 times 32.07 is just going to be 32.07. All right, then I'm going to add them together. So we just do it just like we did for molar mass. So now we've actually found the molar mass for the compound, and if we add these together, it's 159.17. Okay, and that's grams, technically grams per mole, so this would be the molar mass. Now we can take these numbers and use them to figure out what percent of this mass comes from copper and what percent comes from sulfur. So it's really simple. I'm going to start with copper. I'm going to take this 127.1, divide it by the grams of the compound. So that's my grams of my element. So I found out that the compound weighs 159.17. So we divide those two. Oh, sorry. We're going to divide them, and then we're going to times them by 100. So we turn it into a percent. So I take 127.1 divided by 159.17 times 100, and I get about 80%. I think it was 79.8 in the calculator, and I just rounded to the nearest percent. So try plugging this in your calculator and make sure you're getting the same thing. I'm going to do the same thing here. We're going to divide so that this tells me that the 80% is coming from copper. Let's find out how much is coming from sulfur. So I'm going to do the math even though we could assume based if these are the only two compounds that it's 20%. It should be 20%. If copper is 80, then sulfur should be 20%. I'm just going to do the math just to prove that to you. So we take the mass of the compound, 159.17 times 100 equals, and if you plug it in, it's about 20%. So I'm just going to round to the nearest percent. So 80% comes from copper and 20% of that mass comes from sulfur. So the good thing to put on here is the symbol so we know what you're talking about. All right, so that's how we find the percent composition. So hopefully that was easy enough to follow. Let's see then. I'm going to give you one more to try on your own. Okay, so some percent composition practice. I'll give you 2 more. I'd like you to try these in your notebook. When you finish, come talk to me and I'll check your work. All right, good luck.